Good evening, my lovely warriors. Hello, Asil, Ankit, Aishwarya. Hi, Dama. Hello, Clay, Tsunami, Jai. Welcome aboard. This is Shreyas here, your physics master teacher at Vedantu going live. I hope you can see me. I hope you can hear me loud and clear. Put up a yo, put up a smiley, put up a nice heart, put up something so that I know you guys are here. Mark your attendance. Keep the chat box active. Make new friends. And it's time to now finally enjoy, especially the 2021 students. And if you're a 12th or 11th or 10th or 9th standard student, I'm pretty sure you have just come here to see how the advanced paper looks like. Is it scary? Is it moderate? How do the seniors exactly react? How is their performance? Can I do it? Can I not do it? Don't worry, guys. Don't be scared. If you study well and if you are regular in the classes, trust me, you can do well. And we are conducting long-term series for 11th and 12th standard students. The 11th standard series is called Nurture and the 12th standard series is called Pathfinder. So you will find all the playlists, all chapter wise arranged beautifully. You can check it out in the playlist tab. So welcome aboard. Hello Zayed, welcome, 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 welcome. Nice to see all of you. 2022 is waiting. I am also waiting. Let's hope that 2022 comes aram se. I don't want to reach 2022 JEE in a hurry. We have time and let there be time so that we can prepare very well. So those of you who do not know me, I am Shreyas. I am the HOD Physics JEE division. I graduated from NIT Nagpur. I did my research from IIT Bombay, training kids for a very long time and producing results like top all India rank, within 2 digits. And there are hundreds of students of mine who are now in IITs or even graduated from IITs. And many of my students probably are, not just in IITs, they are in, top colleges or good colleges like NITs, BITS, you name it. And many of them have even graduated to some higher institutes doing postgrads, PhDs. And I really hope that this channel becomes a stepping stone in your success, in your career, and you'll remember us forever. So I hope you have already hit the subscribe button. And I hope you have also done us a favor by smashing that like button down there. So go ahead, do that in case you haven't done it yet. And yes, do one more thing. If you want to get regular updates and if you want to get to know more about how to prepare for JEE, the sessions, the timetable, and everything that you need to know for the entrance examinations, go ahead, join the Telegram group link in the description box below. Okay, chalo, let's get going. And here's the first section coming up on your screen now. And well, which subject I don't like at all. I don't want to say it because it might create a lot of controversies. Maybe some other day, Ankit. Okay, after I finish Aishwarya, Shimon sir is going to come. Okay, yep, that's what it's going to be. Yep, Clay Tsunami, finally all exams are over. How happy are you? So I don't know, are you guys like, how is that excitement? I know I witnessed it many years back. After finally all the exams are over, you feel that you have conquered everything. Oh my God, it's done. Now I am finally settled. Okay, nothing more, no more studies. Throw those books. Sir, why are you even discussing? Well, I am discussing so that 2022 students benefit. Also the 2021 students want to know where they committed mistakes, what should have been the correct answer and where they went wrong. It's always good to know where you guys went wrong. Okay, so here is the first section. I think in this more than one is correct. Again, partial marking and also negative marking for marking the wrong answers. Okay, so let's do the first one. Johan can't express it in words. Very true, Johan. It's very difficult. Paper is hard, Rukmini, as compared to the paper 1. So paper 1 was moderate. This one is relatively harder than paper 1. That's what I felt. Hi Anil Kumar, good evening. Hi Nikhil Krishna, welcome aboard. Oh my God, Flona, you have exam tomorrow. Looks like you are a 2022 or 2023 student. Don't worry, तुम्हारी भी बारी आएगी, सबकी बारी आएगी. Everybody will have their turn and they will be like, finally I get to throw all my books and just chill. And it's such a nice feeling, right? Yeah, exams done and it's so cool. Anyways, so one end of horizontal beam of weight W. Okay, there's the beam having weight W and there is another box having weight alpha W. And there is a rope, light, inextensible. This is L, this is also L. That means that's 45, 45, 90. That's obvious. a block is attached, okay, the rope can sustain maximum of 2 root 2 times of the weight. Which of the following statements are correct? The vertical component of reaction, the horizontal component of reaction, the tension, and the rope breaks. Okay, so basically I think we need to draw FBD, use Newton's laws torque equations because there is turning effect, and then probably figure out most of the things and then only proceed with the problem. Okay, this is L, obviously this is 45, this is obviously 90, and this is also 45 degrees. Next thing up over here is that this rod will have its own weight from the center, so I will put it as W. This one over here will act here like this, alpha into W. The tension will have two components, so obviously one component will be T sine 45, which is T by root 2, and obviously T cos 45 here. So I'll just put T by root 2. I'm skipping one step, pretty sure it's very obvious. Okay, from here there will be obviously two components of the reaction at this point. So this is Ny, and you can see there is only one force in the horizontal direction from this side. So there must be another force from this side to counter it. So there must be Nx, the horizontal component of the normal. Understand, this is the reaction on the hinge. The direction is unknown, magnitude is unknown. So it's best to assume two components and then figure out what is happening. These are the only forces acting on the rod plus this, mass system. Rod plus the mass system. These are the only forces. Okay. In the horizontal direction, in the x direction, what I can say is basically Nx is equal to, you can see Nx is equal to T by root 2. There is nothing else. So this is T by root 2. Now for the torque equation, because the net torque has to be balanced, taking the torque about this point, Ny and Nx are passing through this point, so no torque. This weight is producing clockwise torque at a distance of L by 2. So L by 2 into W, fair enough. This T by root 2 is passing through this point, so there is no torque. This tension will produce anti-clockwise torque at a distance of L, so minus, or you can put it on the other side, it's one and the same thing. So minus L into T by root 2, fair enough. And here there is alpha W again at a distance L producing clockwise torque. So again plus L into alpha W. This whole thing will be 0 because net torque should be 0. It is in equilibrium. Okay. Now from this, what you can do, I think L goes. I hope you saw that right now. I hope you saw that coming. L goes. So what I am left with now over here is just T by root 2. Okay. T by root 2. Take it on the other side. W by 2 plus alpha W. Okay. So that means it is nothing but W into, alpha plus 1 by 2. Just check this out. This is what you will get. Now, I think from this, you can get Nx as well. You can take this T by root 2 and put it over here. So this T by root 2, if you substitute it over here, you'll get this as W into alpha plus 1 by 2. Just put it over here. So I found out Nx. So the horizontal component of the reaction force at O is equal to W for alpha is equal to 0.5. Just try to put alpha as 0.5. 0.5 plus half is equal to 1. 1 into W is W. So it is equal to W for alpha is equal to 0.5. Hence option B is correct. You can see that very clearly. Great. I think we can move on to Ny now. So the normal force in the Y direction. So in the Y direction, what are the forces? Ny, T root 2, W and alpha W. Two forces up, two forces down, cancelling each other. So Ny plus T by root 2 is equal to W plus alpha W. Okay, so therefore Ny is equal to W common, so W into 1 plus alpha I suppose minus T by root 2, I can take it from here, just shift it and put it over here. Okay, just take this and put it over here. So minus W into alpha plus half. Okay, so what do we get now? Well. So W is common. 1 plus alpha minus, alpha goes minus 1 by 2. They both go, and 1 minus half is half. So it is just going to be W by 2. So that's what Ny is. So it says the vertical component of the reaction force at O does not depend on alpha, which is correct. You can see that. Hence option A is true. Very good. Excellent. Welcome in all the students who are joining in a little bit late. Hi Bala Darshan, this is the first question. Hello Rukmini, hello Arvind. This is paper 2. Paper 1 will happen probably. Paper 1 has been discussed already in morning. Chemistry discussion will happen probably tomorrow. Okay. Cool, let's get going. Now, the last two things, tension in the rope is whatever. Okay, so I think we can use this equation, just use this equation and try it out. Tension in the rope is 2W for alpha is 0.5. So just put alpha is equal to 0.5. 0.5 plus 0.5, it's 1. So what you are going to get, tension by root 2 is equal to W into 0.5 plus 0.5, which is nothing but 1. So tension is equal to W root 2. It is not 2W. Can you see that, guys? So hence option C is incorrect. Option C is incorrect. The last thing, the rope breaks if alpha is more than 1.5. So put those critical values. What is the critical value of tension? 2 root 2 W. So put that. Okay, so just put 2 root 2 and see what do we get. So 2 root 2 W divided by root 2, if that's the value of the tension. Let's see what is the critical value of alpha. Okay, let's just figure this out. So into alpha plus half. Okay, W goes, root 2 goes. So 2 is equal to alpha plus half. So that gives me alpha is equal to 2 minus half, which is 1.5. So the critical value is 1.5. That's correct. So the rope will break if alpha is more than 1.5. This is basically the critical value. Okay, anything above that, you know, the tension will become more, alpha will become more, and that's it, it will break. Hello Sidhu Siddharth, hi RK coding courses. Hello Sudha Srivarma, welcome aboard. Okay, welcome. Yep, Rinki, yep. Yes, the answers are A, B and D. Good evening. Welcome all my warriors, and if you have not yet hit the subscribe button and also not hit the like button, please do that right now. And we are not only going to conduct these discussion sessions, but also we are going to have some counseling rounds, help you choose your college, so that till you enter the college we are going to help you and you do not face any kind of difficulties. Don't worry. Okay, chalo, moving on to the next question based on Doppler effect. Hi Siddiqui, hello Abhinav, welcome aboard. Come on, let's do this. So what is there in this question? Well, so what do we have? We have a source, we have it approaching with some speed to the open end of a stationary pipe of certain length, and it is emitting a sound of some frequency. The farther end of the pipe is closed, the speed of the sound is V. Okay, fundamental frequency is given. Which of the following combinations will work? Okay, so this is my pipe, think of it this way. Okay, this is my pipe, and the fundamental frequency of the pipe is F0. Now there is a source over here. Okay, there is a source. Okay, I'll call this source, and it is moving with certain speed. Okay, that speed is nothing but U, and the speed of sound is V. Okay, fair enough. Now what will happen? There is standing wave which is created over here, and the question is which all speeds are allowed for what and all frequencies. Let's just try this out. Let's first get a general equation. Basically, for it to resonate, the apparent frequency should be equal to the frequency of the pipe. That's the starting equation. So the frequency of that particular pipe should be equal to the apparent frequency which is being heard. Now what is the apparent frequency being heard and what is the frequency of the pipe? Because this is closed at one end and open at the other end, so all the frequencies will be odd times the fundamental frequency. Do you guys agree with this? Odd times the fundamental frequency. Remember, only odd harmonics are present when it is closed at one end and open at the other end. Don't even have to put 2n plus 1 and 2n minus 1. Not needed. It's simple this way. You will see why. Okay, this is equal to apparent frequency. So Doppler effect formula. So what is the frequency of the source? It is Fs into speed of the sound, speed of the sound. The source is moving, so I'll put u over here. And lastly, it is moving towards it. So I have to increase this ratio. To increase this ratio, I need to reduce the denominator, so put a minus sign. Fair enough. Now, once I have got this equation, probably I'm just going to make use of this for all the options and check which option works and which doesn't. Let's just check one of them and two of them maybe. So u is equal to 0.8V. So let's see what happens. So u is equal to 0.8V. So what am I going to get? Well, Fs is equal to F naught. So this is F naught. Okay, we can put it later on maybe. Okay, so I'll just put Fs V divided by V minus 0.8 times of V. V goes. 1 minus 0.8 is 0.2. So Fs divided by 0.2. 0.2 is 1 by 5. So I'm just going to get this as 5 times of Fs. And on the LHS, F naught was Fs. And here we have odd number. So Fs goes. So the odd number is equal to 5. Obviously 5 is an odd number. Hence this option A works. Is that clear, everyone? Okay, chalo. Let's see what is the next other option. Probably let's see with this one. U is equal to 0.8V and Fs is 2F naught. So let's just substitute, guys. It's just a matter of substitution. So odd times of F naught is equal to Fs into V divided by V minus 0.8 times of V. Fs is 2 times of F naught. Okay, so we have odd times of F naught and Fs is 2 times of F naught. So 2F naught. 1 minus 0.8, 0.2. Same thing. Same jargon out here. So you will have 5 times over here because 1 by 0.2 is 5. Okay, that's what it is. Okay, so F naught goes. 2 into 5, that's 10. So odd number is coming out to be 10. How is this possible? How can an odd number be equal to 10? 2 5s are 10, guys. Not possible. So this is not possible. I hope this makes sense. Similarly, what you can do is figure it out for this and this option, and you will see only one of them will probably match, or maybe two of them. You can check it out. So it's just a matter of substituting it over here and see whether you actually get an odd number or you do not get an odd number. If you don't get an odd number, then you cross it out. If you get an odd number, just mark it. That's all. That's the whole concept of this question, and you will see that probably A and D will give you the correct answers. Yep, Sasi Kumar. Yes, Rinki Verma. Very good, very good. Excellent. So according to me, how was the difficulty? Abhinav, probably I'll talk about the entire difficulty level towards the end. Just hold on. Okay, I'll discuss the entire analysis towards the end. Very good, Moody Goodan. Excellent. Moving on, guys, for the next question. Okay, so what we have over here is, so next question is on a prism. The angle of the prism is 60 degrees. The refractive indices on the left and the right half are different. Very interesting. Okay, interesting. N2 is more than or equal to N1. The angle of incidence is chosen such that the light rays will have minimum deviation if N1 is equal to N2 is equal to N is equal to 1.5. That means when this was a normal prism where everything was uniform, then this angle was so chosen that it had minimum deviation. And we all know what happens during minimum deviation, guys. What happens during minimum deviation? The ray which goes inside the prism is parallel to the base. So this will be parallel to the base. That's what will happen at minimum deviation. And one thing interesting over here, even if N1 and N2 were different, try to understand this. Because this ray is parallel to the base, that means it will be perpendicular to this dotted line. It is perpendicular to this dotted line. So even if N1 and N2 were different, understand this ray would still go like that. Remember, no matter what medium you have, if you have your ray perpendicular to the surface, it does not refract. Only when it is at an angle will it refract. But here, the angle of incidence, refraction, both are 0, 0. That is, it is perpendicular to the surface. So it will still go like that. And probably you can draw one more dotted line. That is nothing but the normal. And it's finally going to come out, emerge out from here. So this is the emergent ray probably. Yep, that's what you can write it as. Alright, now, well, where is it? Is the angle theta given? Yes. This total angle is 60 degrees, guys. if this total angle is 60 degrees, and if you think about it, this angle will be 30 degrees, obviously this angle will be 60 degrees, obviously this angle will again be 30 degrees. Got it? Fair enough. From this, what will I get? I think I'll get the angle of incidence I. How do I get that? Let's try this out. Sine of I divided by sine of 30. Okay, sine of I divided by sine 30. Incident refracted angle is equal to refractive index. What is the refractive index? It is n. What is n? It is 1.5. Achha, it is 1.5. So sine of I will be sine 30. Sine 30 into 1.5. That means half into 1.5 is nothing but 3 by 2, which is 3 by 4. Now there is one small thing which I will do. Okay, probably I'm going to need it. I'll just draw a triangle and keep, because maybe I might need cos I, sin I, tan I, who knows. So how about just drawing a small triangle over here? Okay, I'll just draw a triangle. Okay, this is 90, this is incident. Sin I is opposite by hypotenuse. Opposite by hypotenuse. 4 square is 16, 3 square is 9, 16 minus 9, that's 7. So this will be root 7. Okay, so I have just figured this out. So I don't think I need this any further. Okay, so this is root 7. I don't need this. Okay, just keeping this aside. Okay, now the option says the values of delta E, delta N, etc. Are they proportional? Where does it lie? Who is more? Who is less? So what does this whole expression mean? See guys, this first half you are not even changing. Only the second half is what you are changing. If you change the refractive index of the other medium or the second half, see this ray won't change inside the prism. Reason is because of the angle of incidence. So once it enters over here at 90 degrees, I just explained to you, there is no reason for the ray to deviate inside the prism. Whatever changes will happen will only happen over here. So if N2 changes, this refractive index change. So when the medium changes, the ray will emerge at a completely different angle. So that's the whole idea over here. So if this is 30, obviously we know that this was also 30 degrees. Correct guys? So if N2 changes, E will also change. That's the whole concept. So I'll just probably mention it over here. Okay. So if N2 becomes N plus delta N, obviously this emergent ray will also shift, and you will see that there is a shift of some delta E. Okay, so there will be some delta E shift over here. Oh, by the way, I was equal to E because remember minimum deviation. So at minimum deviation, incident and emergent ray both have the same angles. Okay, so that's what it is. So look at this, you will now understand if the second refractive index changes, the emergent ray will also now come out at a completely different angle. Okay, so now let's apply Snell's law and see what do we get. Oh, probably for here to here. So using Snell's law, N plus delta N, okay, because now the refractive index is different, N plus delta N into sine of 30 degrees is equal to, the refractive index outside is just 1. So 1 into sine of I plus, okay, delta E. That's what I got. Okay, expand this and see what do we get. Sine 30 is half. N is nothing but 1.5. So 1.5 plus delta N into half is equal to sine of A plus B is nothing but sine A cos B plus cos A sine B. Trigonometric expansion. So sine I cos del E plus cos I sine del E. Okay. Now probably I'll start writing it here. Now 1.5 into half, that is 3 by 2 into half, that's 3 by 4. So I'll get 3 by 4 plus delta n by 2 is equal to sine I. Sine I from here, check this out, 3 by 4. Okay, so this is 3 by 4. Cos of del E. Guys, del E is a very small number because del n is very small. So if the refractive index changes by a very small amount, the emergent ray will also change by a small amount. So cos of a very small number is nothing but 1. We all know this because cos of 0 is 1, cos of 0.1 degree is almost 1. So that's why. I hope this is clear. Okay, fair enough. How r is equal to 39? I'm not sure where is r equal to 39. It is not 39, it is 30, bacha. It is 30 degrees. So this is 30 degrees because this was totally 60, this was 30, this is 60. Okay, if this is 60, out of this much will be 30. So that's why angle of refraction will be 30 degrees. I hope this is clear. Okay, it was not 39, it was 30 degrees. Great. Okay, now what we'll do, plus cos of I, oh that's here, root of 7 by 4 sine of delta E. Acha, what do I do with sine of delta E, guys? It's a very small angle. If it's a very small angle, sine of a small angle is that small angle. So just put it as delta E. Fair enough. Oh, now interesting thing is 3 by 4 and 3 by 4 gets cancelled, and what am I left with is delta n by 2 is equal to root 7 by 4 delta E. So delta E is equal to, okay, 4 by 2, 2, and root 7 below into delta n. Very interesting relationship, and now we can start marking the answers. Observe, the value of delta E is greater than delta n. Delta E is more than delta n. Yes or no? Think about it. Well, root 7 obviously has to be more than 2. Makes sense, right? Because root of 4 is 2. Obviously root of 9 is 3. So somewhere between 2 and 3. So this ratio will obviously be less than 1. Okay, this ratio will be obviously less than 1. That means delta E will be smaller than delta n. Here it says delta is more than. So it is definitely not greater than. Option A is wrong. Great. Next up, delta is proportional to delta n. Yes, delta is proportional to delta n. Done. The value of delta E lies between which and which number? That is very simple. If you think about it, guys, this number is less than 1. Delta n, okay, delta n is 2.8. I just told you delta n over here is given to be 2.8 into 10 to the power minus 3. So what will delta E be equal to? Obviously delta E can't be more than 2.8. Delta E can't be more than 2.8. That means maximum will be 3. And it will definitely not go so low that it will go below 2. Obviously, because this root 7 is just 2 point something. So this ratio will be like 0.9 or 0.8 or something like that. So this value, when you multiply with 2.8, it will lie somewhere between 2 and 3. Yeah. So hence option C is correct. You don't even have to calculate. A lot of people in the examination wasted time calculating this. Don't even have to calculate the value of root 7. You immediately should use your brain and think, oh, it can't be more than 3. Obviously, it can't go less than 2 because this is almost going to be like 2 point something root 7, and just that ratio will be 0.9 or something like that. Okay, so that's how you get the answers, and you will see B and C are correct answers to this question. Very good. How many of you got this in the actual examination, guys? I would be very interested to know. How many of you actually got this as B and C? That would be very, very cool. Okay, so let's move on to the next one. Now, hello Arun, JEE Enthuse. Wow, nice name. Hello Amu, welcome aboard. Nice to see all of you. A physical quantity is given and it's E cross B. Guys, this is standard. If you have studied, electromagnetic waves, you would get this very easily. This is nothing but, the unit of, this is nothing but actually very similar to a pollinating vector. It's basically energy per unit time per unit area. So this is actually nothing but intensity, dimensionally. Intensity. Okay, this is intensity. And what is intensity? Intensity is nothing but energy per unit time and per unit area. This is what it is. Now, you just have to figure out whether it is force by length, time, energy, charge, current, energy by volume, power by area, and all of that. So, let's see how many of you guys got it. Arun got it. Wow, very good. Okay, so I'll tell you what. First of all, energy per unit time. What is this energy per unit time? Energy per unit time is nothing but power. So power divided by area is one of the options. So obviously D option becomes correct. Now I think B or C, one of them will be correct. Charge and current, I don't think so it will come. So one of them came out to be here. Energy is same as work. So it is work upon time, okay, into area. And what is okay, area I can write it as length square. Okay, so length square. Okay, so and what is work? Work is force into length, force into length, and this is time, and here you have length square. So here you have length square. So you can see one of the length will get cancelled. So force by time into length. So that is option B. I don't think any of this will obviously match up, because energy by volume doesn't make sense, guys. How can it be energy by volume? Because you have time over here. Charge and current, there is no way charge and current will come over here. So that is also wrong. Yep. So only B and D will be correct. This was very easy question. This was the easiest question of paper 2, JEE Advanced. If you did not get this, you probably missed on these free marks which are just given. Okay, this was also second easy question. Oh, Anil Kumar, I'm going to take must-watch movies for all the students tomorrow. Actually, I was supposed to take it today, but you know, JEE Advanced paper came up, and that's why I had to shift it to tomorrow. So tomorrow 7:30, bacha. Acha, what is this? There is a nucleus and it breaks into two parts. Okay, so you have this nucleus and N, and what happens? It breaks into two parts, P and Q. Okay, so P and Q. Okay, so this was before, okay, and this is after. This goes like this goes like this. Well, momentum has to be conserved, correct? So conserve momentum, and what will you see? Initial momentum is 0, final momentum is minus mass of that P into velocity of P plus mass of Q into velocity of Q. So therefore MP Vp is equal to MQ Vq. So I think one such option is over here. So option C is correct. Vp into MP is MQ into Vq. Correct. Now let's say I call this number as P, which is momentum P. Each one of them has some same momentum. Now next thing, this energy sum is C square delta. This also makes sense. I'll tell you how. See guys, the energy, the kinetic energy comes from the energy of the mass defect. Okay, the mass defect produces tremendous energy. That energy goes into the kinetic energy. So kinetic energy of P is EP. Kinetic energy of Q is EQ. And mass defect is, look at this, delta M C square. So delta M is delta, C square is C square. So this is nothing but your delta M, which is over here. You can see that. So this option A is also correct. Okay, fair enough. I don't think this will be correct now, because this doesn't make sense. Okay, if this is correct, this won't be correct. Okay, you cannot get this now. Now the only thing left is magnitude of the momentum for P as well as Q. Magnitude of momentum for P as well as Q is how much? Okay, so I think I will make use of this equation. Okay, start with this and see what do you get. Energy is momentum square by 2m. Everybody knows this formula. Kinetic energy is half mv square or momentum square by 2m. So it will be P square by 2mp plus P square by 2mq is equal to this delta C square. Delta C square. Okay, I think we need to rearrange this now. Now P square, okay, common, and here you have 1 by mp plus 1 by mq, so that will be mp plus mq upon mp mq, okay, into half is equal to delta C square. So P square is equal to C square. I have delta and I also have 2 and this whole thing, which is mp mq divided by mp plus mq, guys. See guys, this is correct. So momentum square is this much, so momentum will be root of this entire thing. So C will come outside, you can see C is outside, root of 2 delta and mu. What is mu? This whole thing, which is this number over here. So obviously D option is also correct. Yeah, so if you take the root, you will exactly get this equation. Hello Masman, welcome aboard. Yep, so I hope you guys got this as A, C and D. What a brilliant question which came up on your screen now. Okay, moving on to the next one. Okay, this is also an interesting question. Now here you have two loops. one of the loop, the current goes like this, and the other loop, the current goes like that. So let's see how it is. So this inner loop, the current is like this, anti-clockwise. So if it is anti-clockwise, how will the magnetic field be? Because the question is all about magnetic field, where is it, more, less, etc. How does it depend and all of that. Use your right hand, curl your fingers like this, the magnetic field will come towards you. So that means inside this, the magnetic field will be somewhat like this. Okay, it will be like this, okay, towards you. And these lines are going to go like that and going to go inside. So here it will be somewhat like this. Yep. So this is how the magnetic field lines will look like. It will go like that, and yes, it will keep on going like this. Okay, so this is how the magnetic field lines look like due to the inner one. That's it. Now let's talk about the outer one. The outer one, the current is going like this. Okay, the current is going like this, clockwise. So curl your fingers clockwise. The direction of the thumb is inward. So all the magnetic field lines will be inward. So everywhere I'll just show a cross. Be it here, be it inside, okay, everywhere just show a cross because all the magnetic field lines are just going to go inside. Now look at the options. This magnetic field is perpendicular to the xy plane at any point. Yes, no matter where you go in this xy plane, either the field will be in or the field will be out. So it is perpendicular to this plane. Option A is correct. Makes sense. This magnitude of the field depends on the radial distance, which is also correct. So all the points at the same distance from the origin will have the same magnitude of the magnetic field. So if you change R, obviously magnetic field will change. So it only depends on the radial distance. So this is also obvious. Now the magnetic field is non-zero, is non-zero at all the points for R less than R. R less than R means this region. So I'm talking about basically this region. Look at this. I'm just shading this region up. So don't you see, guys, there are some magnetic fields which are inside and some magnetic field lines which are outside. The one due to the red is out. The one due to the outer one is in. And notice one more thing. The current in the outer one, I2, is twice, more than twice as the current inside the inner one. This current is more than twice as the current in the inner one. That means there will be some point where the magnetic field will cancel out. So there will be some point where magnetic field is zero, and this says it is non-zero for all the points. So obviously this option is wrong. Okay, option C is wrong. I hope this is clear. The point, magnetic field points normally outward in the xy plane for all the points between the two loops. Guys, this is obviously wrong. Can you see these x's? Where is it? All the x's are inside. And what is it saying? The magnetic field points outward. This is wrong. It points inward for the region between the two loops. So this is the region between the two loops. It points inward. So obviously C and D are wrong. A and B are correct. Well, how many of you got this question in the actual examination? I would love to know this. A and B are correct. A and B are correct. Okay. So Pratik, I think that's a good score, bacha. Okay. I think you should be able to get it, but still leave a comment after my video ends, after this session ends. I'll just share you a link of the last year cutoff. So probably that will also give you a rough idea of what IIT and what branch you can get. Okay. So just probably leave a comment after the video. Okay. Very good, Hema Kaushik. Very good, Bodu. Excellent, warriors. Moving on to the next one coming up on your screen now. Okay. Now this is section 2. It is numerical type. Okay, you have to round it off to 2 digits, 2 decimals, plus 2 for correct and 0 for no other, for all the other cases. Okay, the question looks scary, but it is actually chindi. I'll tell you what it is. There is a bottle, okay? There is a test tube and there is some air trapped in it. Okay, so there is some air trapped in it. So let's say this is that test tube. Okay, this is that test tube. This test tube itself has some volume. And the water is filled probably till here. Okay, this is the level till which water has been filled. Everywhere outside there is obviously water like this. Okay. Now what happens is I hope you can see that there is some air trapped here. Okay, there is some air trapped here. This air, okay, right now, let's say it is at, how much is the volume? 3 cc, and the pressure is 10 to the power 5 Pascal. So this air is basically 3.3 cc at, this Pascal, 10 to the power 5 Pascal. Now what happens? You squeeze this bottle. The moment you squeeze this bottle, the pressure increases. The moment pressure increases, the water will rise inside this tube. Everybody agrees? So what happens next is this test tube which is there, okay, this test tube which is there, the water fills in more. There is more water which squeezes in because you have increased the pressure. That's all. Now the moment you increase that pressure and the water squeezes in, what will happen, guys? See, this pressure will change. Yes, this pressure will change. You can see that. Okay, this pressure will change. Let's say the final pressure is P, the final volume is V. That's what has happened. So the pressure changes by P naught plus delta P, and the volume decreases. You can see the volume has decreased over here. This volume has decreased now, okay, as compared to this one. So question is, how much is this delta P and delta V? And it is assumed over here that as soon as you squeeze it by that amount of pressure, then what happens when the bottle is squeezed from outside, the pressure inside rises, trapped air reduces. It is found that the tube just begins to sink. That means the buoyant force is not sufficient. Yes, the buoyant force is not sufficient to hold it up. That's all. Okay, so first thing that I'm going to do, guys, figure out what is the volume of the test tube, because the test tube volume never changed. Think about it practically. The test tube volume which was there, that also has some thickness. It never changed in this entire process. It's a solid rigid test tube. Okay, I think it is mentioned, a soft plastic bottle carries an inverted glass test tube. That glass is obviously rigid. So let's see how much will that be exactly. Okay, so to find that out, do I know the mass of the test tube? Yes, mass is 5 grams. Do I know the density of the thick glass? Yes, 2.5. See this and see this. From that, what I will get for the test tube, density 2.5 is equal to mass, which is 5, divided by volume of the test tube. Therefore, volume of the test tube is 5 by 2.5, which is 2 cc. Everybody fine till here? Everybody fine till here? Great. Now, very good, Pratik, you got it correct. Hello, Devi Krishna, welcome aboard. Now, once I got this, what do I need to do? Okay, talk about this situation when it is just about to sink. Why will it be just about to sink? Because the weight of the tube plus air, well, air has negligible weight, so ignore that. So the weight has just been balanced by the buoyant force. So the weight has been just balanced by the buoyant force. So that's when it just is about to sink. If you increase the pressure further, this decreases, the total volume of this object decreases. When the total volume of this object decreases, buoyant force reduces. The moment buoyant force reduces, it will start to sink. That's what has happened. Okay, so let's just do this. Buoyant force is equal to, V rho G, but I do not know that new volume. Achha, can I do something about it? Maybe, I don't know. Let's figure this out. So what I will do is, I'll write down one more equation. I think it is mentioned somewhere that temperature is constant. Yup, temperature is constant. You know what it means? PV is constant. That's right. So temperature is constant. That means pressure into volume is constant. So don't have to worry about the units. Just keep the units same on LHS and RHS. So pressure is 10 to the power 5 into 3.3 is equal to final pressure into final volume. What is the final pressure? Well, I don't know. Okay, it's final pressure into final volume. Is the final volume known? No, I don't know that. I'll just put it as V. Okay, that's what I have done. Now, what I can do is, probably put this buoyant force is equal to the weight, and this buoyant force, okay, this buoyant force will be total volume rho g, total volume, V total. V total will be the volume of the air plus volume of the test tube, into rho of water, okay, into G is equal to weight. What is the weight of this tube? That's 5 gram. So 5 into G. That's all I have done. So it's the mass of the test tube into G, if you want to write it like that. Cancel this G. This density of water, remember, it is 1 gram per cc. Standard value. V, I do not know. Volume of the test tube, I know that is 2. Okay. This is equal to M is nothing but 5. So from this, I'll get V is equal to 3 cc. Interesting. I got the volume as 3 cc. If I got the volume as 3 cc, what was the old volume? It was 3.3 cc. So I think I found out the value of delta V. So delta V will be 3.3 minus 3 cc. So which is nothing but 0.3 cc. So the value of X is 0.3. That's all I got. Okay, I got the value of this. So the only thing left is probably this one now. Now this is very easy. So just put these numbers. 10 raised to 5 into 3.3 is equal to final pressure into final volume. What is the final volume? It is 3. Okay, into 3. So therefore pressure is equal to 3.3 divided by 3 is 1.1. So 1.1 into 10 to the power 5. What was the old pressure? It was 1 into 10 to the power 5. So what is the delta P? Delta P will be 1.1 minus 1 into 10 to the power 5, which is 0.1 into 10 to the power 5. But they have asked in 10 to the power 3, right? So this is 10 to the power 4. So this will be 10 into 10 to the power 3 Pascal. That's it. So the final answer over here will be 10. That's it. Done, done. Okay, so Sugandhan, you can watch the replay. That will be the best thing to do. The whole idea over here is this test tube had some air trapped here. The density was overall very less because air occupied a lot of volume. It provided enough thrust force. The moment you increase the pressure from outside, the air's volume decreased. So because of which the buoyant force reduced and it just began to sink. So when it just began to sink, buoyant force is equal to weight. So buoyant force is equal to weight. Buoyant force will be the total volume of the tube plus the air. So tube plus the air over there into rho into G is equal to the weight. Weight will be of the test tube only because the air has negligible mass. From that you will get volume. Using Boyle's law, you will get the final pressure. From that you will get change in pressure and change in volume. Hello Riza, welcome aboard. Karthik, check it out. Your settings might be set to lower video resolution. Go to advanced settings on YouTube and increase the resolution in advanced settings on the right bottom corner. Okay, so yep, that's the answer, 0.3 and 10. Excellent. Moving on to the next one. Cleared Suthan Sri Varma. Very good, very good. Okay, chalo, moving on to the next one. So what do we have here? We have a pendulum of certain bob, mass this much, and it is inextensible. Length of the string is 1 meter. It is suspended from a height of 0.9. Now what it means is that, see, there is a frictionless floor. That's the floor. This height is 0.9. This height is 0.9 meters. This bob is over here. You give an impulse because of which the bob goes till the length of the string will become how much? 1 meter. So this is basically 1 meter. The moment it becomes 1 meter, the bob which was going this way will suddenly turn and you will see the new direction will be like this. Okay, because now it will become perpendicular. The bob was going like this. The string became taut. Now it will go in a circular motion. Okay, it will go in a circular motion, vertical circular motion. Till this point it was straight line. After this it is a circle of radius 1 meter. Fair enough. Okay, let's assume this final velocity to be v. Let's assume this initial velocity to be u. It just goes with that constant speed u. Reason, it's given to be a frictionless horizontal floor. The bob is given a impulse of this much, and after sliding that distance, you know, it goes up. Okay, so just before the takeoff, the angular momentum is J and the kinetic energy after liftoff is K. How much is J and K? Straightforward question, guys. Don't have to break your head so much. Okay, the impulse is given, right? So if you give the impulse, okay, if you give impulse, what does impulse do? Impulse changes the momentum. So impulse is basically change in momentum. So if that is the case, what's the impulse, guys? It's 0.2. What is the change in momentum? Mass into velocity. Mass is 0.1. 0.1 into velocity. Velocity I do not know. I'll just assume it as u. So therefore u is equal to 2 meters per second. Straightforward. Next up, see, when the string suddenly becomes tight, till this point the string was loose, correct? The string till this point, okay, it was nothing but loose because the length of the string is more than these 2 points distance. Suddenly it becomes tight. So don't you see, guys, there will be a sudden impulse over here as well. Sudden impulse by tension over here. If that's the case, think the momentum will change in this direction, but the momentum won't change in this direction. Correct, guys? The momentum will change in the direction of impulse, but in the perpendicular direction it won't change. So in that perpendicular direction, what's the momentum? Let's figure this out. First of all, let's say this is theta. If this is theta, obviously this angle will be theta. You can find it out very easily by dropping a perpendicular here. If this is theta, obviously this is theta. If this is theta, this is 90 minus theta, this is theta. Okay. So what is the momentum along that perpendicular? So momentum perpendicular to the string is conserved. This is very, very important. Momentum perpendicular to the string is conserved. What's the initial momentum? It is mu cos theta. What's the final momentum? It is just mv. M goes, u is 2 cos theta. Cos theta is adjacent by hypotenuse. So that's 0.9 divided by 1. Okay, that's equal to v. Therefore, v is equal to 1.8 meters per second. Great. I found out all these things. I think I can also find the kinetic energy. So kinetic energy will be half into mass, which is 0.1 into 1.8 square. See if this makes sense, guys. Correct? So now, what is 18 square? 18 square is 324, correct? Very good. So if 18 square is 324, the half of that will be how much? 162, right? So 162 divided by 162, sorry, into 10 to the power minus 3. So this will be 0.162 joules. So this will be 0.162 joules. The last thing remaining is what is the value of J? What is the angular momentum? Okay, so that you can figure it out by what do you need to do? Angular momentum, right? MRV. Okay, simple. So angular momentum, but that is just before the bob lifts. M is 0.1. R, do not take this as R. R is the R perpendicular because the velocity is this way. Okay, the velocity is this way. So R perpendicular, that is just 0.9 into velocity. Where is the velocity? Velocity is 2. That's before, because it is clearly mentioned before. Everything is before. So that's 9 to the 18. So 1.8. So that's 0.18. Yep. So that's 0.18. So just put 0.18 over here, and that's the answer. Such a brilliant question. Okay. Yep. So that's how it is. You can watch the replay if you want to see the again explanation really fast. You can take the replay. Okay, moving on to the next one, 0.18 and 0.162. Okay. Thank you, Karthik, for all the love, bacha, from AP. Okay, moving on to the next one. Now over here we have a question on, I think, AC circuits. Guys, there is a very weird way of solving it, but I'll tell you the easy way of solving the question. You don't have to break your head so much. Okay, so in this circuit, capacitance across this 200 volt, sorry, the voltage across the capacitance, wait a minute, hold on. A metallic lamp is connected in series with a capacitor of capacitance C across a 200 volt 50 hertz supply. Okay, that's the supply. Fair enough. So what is happening is you have a supply of 200 volts 50 hertz and you are connecting a capacitor and also a bulb or a lamp like this, and across the resistor I think the voltage is 100 volt. Yes, so across this there is 100 volt and obviously there will be some current and all of that, and there will be some voltage across the capacitor as well. Okay, the first thing that you can do is, since it is clearly mentioned 500 watts of energy per unit time is released, so this is 500 watts, so power is equal to VI. So power is 500, V is 100 into I, therefore current is 5 ampere. That's one thing, probably I need it later on. One more thing that I can do is draw the phasors of voltages. So voltage across the resistor will be horizontal, which will be 100. Voltage across the capacitor will be down, so that will be VC, and this will be the total voltage, which is 200. And we all know that current is in this direction. This is the final voltage, so this is phi. So cos of phi, because I think they have asked phi value, so cos of phi will be adjacent, which is 100, divided by hypotenuse, which is 200, which is 1 by 2. So phi value is 60 degrees. So I think I got the value of phi, which is 60 degrees. Okay, I'll just put the value as 60 degrees. Okay, first answer is done. The value of C. Okay, for value of C, I think I can do from here. VC will be root of Pythagoras, guys. 200 square minus 100 square. Take 100 outside, the root, so it will become 100. Root of 4 minus 1, which is 100 root 3. Next step will be, we all know voltage across the capacitor is current into XC. And what is this XC? It is 1 by 2 pi FC. 1 by omega C is nothing but capacitive reactance, just use that. Okay, so VC is nothing but 100 root 3. Current, I think I found it out, probably now I can use it. So that's 5 into 1 by 2 pi F is 50 hertz into capacitance. Bring that capacitance there. So this will be 5 divided by 2 into 50, that's 100 pi. This will be 100 root 3. Okay, that's what I get. Now you should understand pi into root 3 is already given. Pi root 3 is 5. Okay, so pi root 3 is 5. So root 3 pi and 5 just goes. So I'm just left with 1 by 10 raised to 4, which is 10 raised to minus 4. The final answer I think is in, yep, this C is microfarad, be careful. So this will be 100 into 10 to the power minus 6 farads, which is 100 microfarad. Hence this answer is 100. That's it. Done. Okay, so you can see that I have solved the problem in a very easy manner using phasors, simple geometry, Pythagoras, and simple formulas by definitions. Nothing great about it. Hello Ankita, hello Dilip, welcome aboard. Exam did not go well, all hopes lost, not feeling well. Don't worry, Damesh, you are not a loser. You still have one more chance, bacha. One more year is there. You can still work really hard. Nothing is lost. I mean, it's just ups and downs. Don't worry. I mean, see, somebody has to get in, somebody has to get out. So maybe it was just not your day today. Maybe next year might be your year. And maybe for God knows, if you scored well in JEE Mains, probably you might get a good college. So let's see how it goes. Probably you can leave a comment after the video and let's see what colleges you can get through, and if you are not willing to take a drop, and if nothing works out, then maybe you can take a drop. Don't worry, bacha. Okay, chalo, let's move on to the next one. Okay, 160, that's it. Okay, by the way, our classes in the droppers batch will look something like this. The teacher will be here, quizzes, chats, 2-teacher model where you can ask any doubts with leaderboards, points, all fun quizzes. So that's not on Google Meet. Also, the recordings are available till the end of the course. and we'll be teaching right from 11th standard portions till the 12th standard portions. So that's the dropper batch, and this platform is called as the wave platform. I think it's very important for you guys to realize that we do not use Google Meet or Zoom, which are very primitive ways of conducting the classes. So these classes are on advanced technologies which can give you right inputs, it can give you the right feedback, not just the students but also the teachers, so that the teachers know how the students are performing in the class. Moving to the next question coming up on your screen. This is section 3, guys. Okay, just read it up. Okay, just read it up. Let's see if we can get this. Now, there are 2 questions, paragraph based, and each question has 4 options. Only one of them is correct. Wow, such a big question. Read it if you want to. I'll just move aside. Okay, take your time. Now, I'll give you a gist of this paragraph. This was the passage. Unnecessarily, they have confused you. I'll tell you what it is. This is like a superconductor. Okay, no resistance, and it does not allow any change in flux. So no matter what happens, it does not allow change in flux. There is a magnetic dipole. What does the dipole do? Create a field. Some of the field will pass through this, correct? Now if you move this dipole closer, what will happen? The flux will change. But what is this coil? Special coil. So what will it do? It will try to oppose it by creating a current, and it will oppose the change in flux so that the total flux remains the same. That's what it is doing. Okay, this distance r is very large, and we know the field due to a dipole formula, mu naught m by 2 pi r cube. Okay, that's the standard formula. So magnetic field of a dipole, that's what it is. And the force, okay, the force between the 2 dipoles is given by k m1 m2 divided by r raised to 4. So if there are 2 dipoles, that's the force between them. That's what is given. So based on that, we have 2 questions. This is question number 1. Oops, I don't want to show you the answer. Yeah, question number 1. Okay, and it says that the current in the loop will be proportional to which quantity? Okay, remember here m is the dipole moment. I'll explain it to you. It's not that difficult. The passage looks scary, but trust me, this was one of the easiest questions if you know the correct formulas. Yes, Nikhil, very short question, very easy. Tuck, tuck, tuck. So what you need to do, this dipole will create a field around it. Okay, this dipole will obviously create some field around it. Some of the field lines, okay, just think about it. This is how the field lines will be. Some of the field lines will obviously cut through this loop. Okay, so there will be some flux. So flux due to the dipole in the loop. There will be some flux. Because of this, obviously there will be some current, and that current, okay, will create an opposing flux. So this current will create its own magnetic field, and obviously there will be some magnetic flux created just because of that. Okay, so this is what it is. Okay, interesting. So this is nothing but the induced flux. It was mentioned in the question that this is a special coil which does not allow any kind of change in the flux. That means the induced flux, the green one, should be numerically equal to the flux due to the dipole cutting through this particular loop. So I'm just going to say the flux which is induced numerically will be equal to the flux due to the dipole. Okay, due to the dipole. Now what is the flux due to the dipole? Flux due to the dipole will be the magnetic field of the dipole, okay, multiplied by area, which is pi a square. What is the magnetic field of a dipole? I think it was just mentioned over there, correct? It was nothing but mu naught by 2 pi, I think m, and you had r cube over here, correct? You had mu naught m by 2 pi and r cube over here, and that's obviously nothing but pi a square. Okay, I'm just substituting everything. What is the flux induced in a coil? Flux is Li. L is self-inductance. That's the property of a coil. So L into current induced. Why am I writing this formula? Because the question is what is the induced current in the coil? So this is the induced current. So from this I'll get L into I induced, So from this I'll get I induced is, okay, just ignore everything else, just see what is it proportional to. Do you see one m over here and do you see one r cube over here? Rest all things are constants, so basically it is just proportional to m divided by r cube. Is m divided by r cube here? Yes, it is there. That's it, that's all that was there you need to do. Look at the number of steps. 1, 2, 3, 4. 4-step problem. 4-step problem. That board was completely filled with that passage, but it was not so difficult, guys. Okay. Remember, probably will let you know about the expected cutoffs and everything very soon. We have just got the paper and we are also getting the reactions of the students. So probably, by tomorrow or day after tomorrow, we'll be able to tell you about something. Now, m by r cube was the current. Okay, so current was proportional to, so what did we get? The current was proportional to m divided by r cube. Now the next question is, what is the work done in bringing the dipole from infinity to this distance? Guys, to do this question right, you don't have to do much. Remember, there was a formula for energy. So that work done will be in the form of energy stored in that, energy stored in that coil. And U is nothing but M, okay, dot B, or if you want MB cos theta, okay, so cos theta doesn't matter. Anyways, cos theta when theta is 0, so don't worry about it. That minus sign, even if it is there, ignore it, because I'm not interested in the plus minus signs. I'm just interested in the magnitude, guys. Okay. Now, what is the magnetic moment of that coil? The magnetic moment of that coil, guys, is NIA. N is 1. That's number of turns. It's one coil. I is I into area is pi a square. Okay, fair enough. Into B. What is B? B is the magnetic field by the dipole. This is the magnetic field of the dipole. This is the external field. This is the coil. I hope you remember this. The coil was here. The field was coming from external. That is the dipole. Okay, so this was the external field. We have seen this formula for a dipole placed in somebody's field. So that will be mu naught by 2 pi into m divided by r cube. Now the interesting part is pi a square, everything else is constant. Current is proportional to m by r cube. So that means it's some constant into m by r cube into pi a square into mu naught by 4 pi into m by r cube. M by r cube, this will be some another new constant into m square by r raised to 6. So that's what the work done is proportional to, m square by r raised to 6, which is option C. Done, done, done. I hope this is clear. Great. What a easy question if you solve it in an easy way. Else you will just get stuck endlessly doing some integrations, some derivatives, not at all needed. Direct formulas, U is m dot B. That's all. You just have to see whether it is proportional to which power of m and r. Okay, moving on. So guys, what do you guys say? Is this paper difficult than the paper 1? Are you guys tensed? And yeah, what? Is this difficult or was it relatively okay or similar level? Not? No? Okay. It's okay. Cha. Let's try and do the next question on thermodynamics. These kind of questions are very interesting because they involve mechanics plus thermodynamics both together. Now, there are 1 moles of gas, I think. Cv is given and there is the ideal gas. The R is the gas constant. Each side has the same volume, same temperature. It's given, okay. Everything is insulating and you supply heat only to this gas. What will happen when you supply heat to this gas? Obviously, it will try to expand and this chamber will try to move. It goes here. But will the heat go from here to here? No. Why? Because everything is insulating. Okay, ignore the changes in cylinder, heater, partition, everything. None of them transfers energy. This will get compressed, this will get expanded, but the temperature will increase here, so pressure will also increase until, the pressures are same on both the sides. So let's just put over here, and I think the right side volume becomes V naught by 2. Okay, so this becomes V naught by 2. Okay, so here, if it was V naught, it compresses this by V naught by 2. Obviously, this volume will be 3 V naught by 2. Obviously, the pressure on the left side should be equal to the pressure on the right side, undoubtedly. only then it will reach the new equilibrium. Fair enough. This is the new temperature TL, and this is the new temperature of the right side temperature. Okay, now, acha, what is the question? Well, actually the question is on the other slide. Now I don't want to erase it. Let me just read the question from here. I think the question is, acha, I'll write down the question. The question is TR by T naught is equal to how much? That's the first question. And the second question is Q by R T naught is how much? Q by R T naught is equal to how much? Okay, that's the two questions on this passage. Okay, a lot of things to find out. TR and T naught, right side temperature. I think we can use adiabatic process law, and that is TV raised to gamma minus 1 is constant for adiabatic process, okay, in the right side. Okay, we can use it. Why is it an adiabatic process? Because I'm slowly supplying the heat, the chamber moves slowly, it's a slow process, number one. Number two, there is no way the heat can escape out of this second gas. Okay, the heat is only given to the first gas, not to the second gas. Okay, so TV raised to gamma minus 1 is constant. Oh, but I don't know gamma. I think I can find gamma because CV is given. So CV is 2R. CP is always more than CV by 1R. So it will be 3R. And gamma is CP by CV. So it will be 3 by 2. Fair enough. So now let's do this.
To do that, you'll need to turn off airplane.
Oh my god. My Siri is crazy. Alright. So gamma is 3 by 2. Now temperature. Temperature is T naught. Volume is V naught. Gamma minus 1. That means 3 by 2 minus 1 is equal to final temperature. That's TR. Volume is V naught by 2 into 3 by 2 minus 1. Okay, so what do I get? T naught into root V naught, because 3 by 2 minus 1 is half. Half power means the root. Okay, that's TR. This is also root of V naught by 2. Okay, but I think I want TR by T naught. So TR by T naught. So T naught goes there. Root 2 comes on the top. So that will be root 2. Done, done, done. So TR by T naught, I just figured it out that it is nothing but root of 2. Okay, this one is done. Okay, this one is done. Okay, I don't think I need this anymore. Moving this out. Okay, now for the heat supplied to the gas, try to remember or try to understand that the heat will go into two things. Number one, it will increase or change the internal energy of system on the left side and also change the internal energy of the system on the right side. Work done will be zero as a whole. Reason, whatever positive work is done by the left gas, the same negative work is done by the right gas. So whatever work you do is going to go, whatever heat you give is going to go into changing the internal energy. So I can probably start my statement by saying Q is equal to work done plus delta U total. This total work again is obviously zero because no change in the total gas volume. Okay, plus change in energy of the system will be change in energy of the left side plus change in energy of the right side. Delta U is always NCV delta T. So N, it's 1, right? 1. CV is 2R into delta T. Delta T is final minus initial. So TL minus T naught plus again 1 into 2R into delta T. What is delta T for the right one? Okay, TR minus T naught. Okay, TR and T naught I already know. TR is root 2 times of T naught. The only thing I do not know is TL, guys. How do I find TL? How do I find TL? Think about it. I think I will have to apply a law over here. But I cannot use, adiabatic process because this is not adiabatic. I am supplying some heat. So I think I'll have to use general equation. P1 V1 by T1 is equal to P2 V2 by T2. There is another problem. I do not know the pressure. Yep. So that's the crazy one. So what you need to do, you need to first find the pressure on the right side. Only then you will get the pressure on the left side, and only then you will get the temperature on the left side. So, lengthy process, but let's do this. Okay. So PV raised to gamma is constant. So PV raised to gamma is equal to constant for the right side. Let's try and do this and see what do we get. Okay, initial pressure I think is given. Okay, let's just assume it as P naught. I guess it's not mentioned, right? Anyway, just check this out. It's not mentioned. Okay, so let's just assume it as P naught. Okay, so P naught into volume V naught raised to gamma. Gamma is 3 by 2 is equal to new pressure on the right, into final volume V naught by 2 raised to 3 by 2. Okay, so pressure on the right will be, what will happen? P naught will be as it is. V naught goes 2 raised to 3 by 2. Well, pressure on the right and pressure on the left is same. So I'll put PR as PL. Okay, that's what I have done. P naught as it is. 2 cube is 8. Root of 8 is 2 root 2. So P naught into 2 root 2. Okay, so I got PL. Once I get PL is equal to PR is equal to, okay, so this was P naught, this was also P naught. What did I get it as? P naught 2, that's equal to P naught 2 root 2. Okay, just put it over here. I don't need this anymore. Again, for the left chamber, so for the left side gas, what am I going to do? Use your general gas law equation. P1 V1 by T1 is P2 V2 by T2. That's all. Why am I doing this? Because I want TL, guys, only for that. Okay, so P1 V1 by T1 is equal to P2 V2. Okay, what's the volume? Is the volume known? Yes, 3 V0 by 2 by T2, which is TL. So let's just start substituting. P0 V0. I think that V0 goes from both sides. P0 by T0 is equal to PL. PL is P0 2 root 2 into V0 has gone anyways. So 3 by 2. TL, oh, that's what I need to find. P0 goes. Let's just see what and all has gone. V0 had gone, P0 gone, 2 also gone. So I am just left with TL is equal to T0 3 root 2. Interesting. So TL is nothing but T0 3 root 2. Fair enough. So just substitute it over here and I think that will give you the answer. Okay. So 2R, TL is 3 T0 into 2 root 2, root 2. So 3 root 2 T0 minus T0 plus 2R into, what is TR? TR is root 2 T0. So root 2 T0 minus T0. Okay, 2R is common and let's see what and all do we get. Oh, even T0 is common. 3R T0 is common. So 3 root 2 minus 1 plus root 2 minus 1. Okay, so I'll get 2R T0. 3 root 2 plus root 2, that's 4 root 2 minus 2. Minus 1 is minus 2. So I think you can still take 2 common outside. So I'll be left with 2, if it goes outside, 2 into 2 is 4. So 4R T0, okay, and I have 2 root 2 minus 1. That's the answer. Yep. So Q by R T0, that's what the question said. So Q by R T0, okay, will be nothing but 4 into 2 root 2 minus 1. So that is the answer. Okay, that's the answer. Did you like this question? How many of you were able to do it? How many of you were able to do it in the actual exam? That would be crazy. Tanuj, Shimon sir will come after my discussion is over. There are a few more questions and then Math sir will be ready. Yep, Shimon sir will be ready. Okay. What a question, guys. What a question. Yep. Moving on to the next one. Yep. So this value is, and this value. So one of them was root 2, like I just got it. And this was 4 into 2 root 2 minus 1. Yep, both are correct. Okay, section 4, last section I guess, I don't know. Okay, moving on. And here we have a meter bridge kind of an arrangement. This is null point, this is E by 2, this is E, this is R1, R0 by 2, resistance, everything is given. The question is If the null point is found at 70 centimeters, what is the internal resistance R1? Rajiv Pratap Jadhav, class 12th regular classes, my syllabus is over, term 1 syllabus. So now we'll be doing the revision, and term 2 syllabus will start after some time once your term 1 examinations are over. Okay, term 1 syllabus physics is over. There is probably one lecture left, which is transformers. I'll be doing it tomorrow or day after tomorrow, and we'll be doing revision, practice, KVPI practice, term 1 practice, HOTS questions, all of that. Okay, so that's what we're going to do. So you should be proud and happy that the syllabus for term 1 is already over. And now we are going to go to KVPI and other such examinations as well. Okay, so let's see what we can do over here. It is a null point. Okay, if it is a null point, then obviously there will be no current which will be flowing in this branch. Let me redraw the circuit. So this will be the EMF E, this will be R1, okay, this will be R0 by 2, but I think R0 is 50, so that will be 25 ohm, okay, and here like this, and there is no current flowing here, so ignore this part, but this branch and this branch have some resistance. See, the total resistance of the wire is 50 ohm. Can you see that? It is totally 50 ohm, guys. That means this much part will have some resistance, that much part will have resistance. What will be the resistance of the L part? That's simple. See, find the resistance for the entire length. What is it? 50. For how many meters? 1 meter. For 72 centimeters, how much will it be? That means 0.72 meters, how much will it be? So that will be 720's half. That's nothing but 360, but I have 10 over here, so 36, yeah, 36 ohms. Yeah. So this resistance is 36 ohms. So think of a resistor of 36 ohms here, and the total resistance was 50. This total was 50, this is 36. How much is the remaining now? Obviously, it will be nothing but 14 ohm. So this is a simplified diagram of the same circuit. Now it looks easy to solve, correct? What I have done over here, I hope you guys got it. So let's try and do this question and see what do we guys get. What do we do now? Okay, let's probably just show this part over here. Okay, there was this E by 2, I suppose. Okay, the current over here in this branch is 0. Okay, this is E by 2. Okay, now what we can do, let's say there is some current flowing over here like this. Okay, current flowing over here like this. Okay, now what you need to do is basically apply Kirchhoff's law and try to solve the question. Okay, so let's try to apply Kirchhoff's law and see what do we guys can get over here. Okay, for this guy, let's start from here and see what do we get if we go and come back to this point. So I have minus I R1 plus E minus 36I positive to negative, so minus E by 2 is equal to 0. Okay, fair enough. So I will get E minus E by 2 is E by 2 minus is equal to 36 plus R1, 36 plus R1 into I. Okay, but I don't know R1, I have to find that out, and I don't even know I. Okay, how about using Kirchhoff's law for this particular loop, and maybe I'll get something. So again, start from this point, go like that and come back. So I'll get plus E by 2 minus 14I minus 25I is equal to 0. I came back to the same point. So therefore, E by 2 is equal to 14 and 25 over there, correct? Just check this out. So that means it is 39 of I. Okay, I think from this I can figure out few things. Oh, E by 2 is 39I. I think I just got it. E by 2 is 39I. So just put it over here. So it is 39I is equal to 36 plus R1 into I. I goes. So 39 is equal to 36 plus R1. R1 will be 3 ohms. That's it. Done, done, done. What a brilliant question, guys. What a brilliant question, है ना? So Kirchhoff's laws, idea of converting this circuit into a simpler circuit, also understanding total length had 50 ohm, so 0.72 meters had how many ohms, and remaining part will have 14 ohms. So drawing that simple circuit was the critical part. Yes, Dilip, hello, welcome bacha. Okay, so moving on to the next one coming up on your screen. Yep, the answer is 3 ohms. The distance between the two stars of masses this and this is 9r. R is the mean distance. They move in a about their common center of mass with time period nt. T is the time period of Earth. So guys, standard question this came in JEE Mains so many times, you should have been able to do this. Chalo, let's do this question. This is 3m, okay, and this is how much? 6m, and the total distance is how much? The total distance is 9r. Obviously the center of mass will be somewhere over here. This is where the center of mass will be, and it will divide it in the ratio of 6:3, which is 2:1, inverse of that. So this will be 2:1. So divide 9r into 2:1. That means divide 9r into 3 parts first, 3r, 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 and obviously this will be 6r, and obviously this will be 3r. Inverse ratio, that's what center of mass does. Now what happens is this mass goes like this mass goes like this, and there is a force of attraction between them, which is providing the centripetal acceleration. So just use your Newton's law, guys, you will get it. So the force will be m into AC, and that centripetal acceleration, okay, what is that m but? Okay, that's another thing. So that force will be mass. You take, let's say, 3m mass, doesn't matter. So 3m into centripetal acceleration. This force will be g, m1, m2. That means 3m into 6m divided by 9r whole square is equal to 3m. Acceleration, I'll write it as omega square into radius. Radius is just 6r, be careful. So this is 6, okay, r. Okay, now I think I just need to solve this a little bit. Dekhte hain. So this m and this m goes, this 3 and this 3 goes, this 6 and this 6 also goes, and therefore omega square will be equal to g m divided by 9 square, that's 81, r square as it is, one more r coming from here, but this is omega square. Omega square is nothing but 2 pi by t whole square is gm divided by 81 r cube. I do not want 1 by time square, I want time period. So invert it, guys, just flip it around. So t square will be, so t square by 2 pi square, so it will go that side. So 2 pi square into gm divided by 81 r cube. So take square root on both sides, you will get 2 pi root gm divided by r cube. Root of 81 is 9. What is this quantity? What is this quantity? This is the time period for Earth. This is the time period for Earth, correct? And oh, I think I had to flip this, my bad, guys, I'm so sorry. I had to flip this here also. I had to flip this because I flipped that. I had to flip this over here. So 81 r cube divided by gm. Now take roots on both sides. So t will be equal to 2 pi. Root of this will be r cube by gm. Root of 81 is 9. We know this is the standard formula for time period for the Earth to revolve. So this into 9. So therefore the final answer is 9. Done, done. Yes, Lalit, obviously it will be tough because it's not easy to become an IITian. So obviously it's challenging. Number 2, to reach that league, you need to work really hard. You need to be really focused. You need to be dedicated. You should have studied very well. Only then you will get that privilege. That's why IITians have so much of respect, because they solve these kind of questions They are able to think in these kind of dimensions. They are able to, it's not just about physics, chemistry, maths. A lot of people think IITians can only solve physics, chemistry, maths because they cleared that entrance. No, it's about ability to think, to visualize, analyze the situation, and having those skills for solving those problems, any problem. So what IIT does, it tests problem solving skills. How is your approach? It's not about getting 100%. Boards test your skills for getting 100%. IITs never tests your skills to get 100% marks. It's about, even if you get 50-60% marks in IIT, you get a very good rank. So it's about how you solve and approach. That's what it is. Yep, you can watch Bacha for NEET, but it might be difficult, especially the advanced ones. So watch the JEE Mains classes. Okay, next question coming up on your screen. Hello Surya, hello Dilip, welcome aboard. And this is on photoelectric effect. The maximum kinetic energy of the metals are EP, EQ, ER. Okay, fine. EP is this much times EQ times 2R. Okay. The same source of monochromatic light is used for P and Q. Very, very important. Acha. The same source of monochromatic light is used for P and Q, while different source for metal R. The work functions of the metals P, Q, R are 4, 5 and 5.5 respectively. What will you write? So, here is what I'll write. Energy of the light, that is not given, right? So energy of the light will go into two things: work function plus energy, of that electron. So I think it is given the maximum energy of the photoelectrons. This is the electron. So use this and see what do we get. First one, for P, okay, so for P, let's say the energy of the light is E1, work function is 4, plus energy of the electron is EP. So I'll just put EP over here. Next, same light is used for P and Q, very, very important. So if this was for P, so for Q also the light used was same, so it will still be E1 only. The only thing that will be different is the work function, which is 4.5, and it will be EQ. But wait a minute, EQ into 2 is EP. So I think I can do something over here. So this will be 4.5 plus EQ is EP by 2. Just take that 2 below. So EQ will be EP divided by 2. So just put this as EP divided by 2. I'm just putting everything in terms of EP, and this is obviously E1. Lastly, R. Okay, so if you want, I'll just put it over here, maybe. Okay, so for R, what do we have? It will have some another energy. Let's say E3 is equal to work function is 5.5 plus ER. ER is EP by 2. Okay, so it is ER over here. So this is 5.5 plus EP divided by 2. That's what I got. Everybody fine? Yep. Now, what do we need to do? Let's see. The question says the energy of the incident photon is how much? Basically, this is asked. How much is this? Oh, for that, I need to know EP. How do I know EP? I think from these two gentlemen out here. Guys, equate these two. Okay, so let's just equate both of them and see what do we get. Okay, let's just equate both of them. These two, if you equate, what you will have? You will have 4 plus EP on one side, and on the other side you will have 4.5 plus EP by 2. Okay, okay. EP minus EP by 2, what will it give? What will it give you? EP by 2. EP by 2 goes there. EP minus EP by 2 is EP by 2. 4.5 minus 4, that's 0.5. So what is EP then? EP is just 1 electron volt. Okay, what will you do next? Use this over here. So this will be 5.5 plus 1 divided by 2. What is 1 divided by 2? 0.5. 0.5 plus 5.5, that's 6 electron volt. Hence the answer is 6 electron volt. This was like a funny equation, guys. The dropper batch cost is around, I'll let you know, it's close to around 40-50,000. So depending on which packages you take, and you also have the option of paying via EMI. So it's around 3,000 to 3,500 rupees per month. That's what you can think of it. 3,000 to 3,500 or 3,700 per month, around that. Okay, so that's what it is, guys. What a brilliant question, right? Yep. Oh, earlier question in the previous one was in IMO. My God, really, this was not so difficult also. Okay, so that's the answer, guys. Okay, now many of you are interested in the dropper batch, and let me tell you, the dropper batch starts Monday. Do not delay the decision. Option to learn in English as well as Hindi from teachers like me, even better than me, I would say. Option to join additional courses free of cost wherever you feel you need help. Let's say you want to learn rotational mechanics again in a very detailed manner. Special course for rotation freely available. Let's say you want problem solving courses for some, chapters. Those are also available. Next up, you also get live teaching. That's very important. 11th and 12th standard syllabus both are completed, and you get the recording, and that recording is available till next year JEE Advanced. That's very important. And you will get tests after every class, tests after every chapter. You will get assignments you will get assignments after every chapter. You will get assignments after every session, and you will get tests after few classes or few chapters are over. There will be also mock tests towards the end. Not just that, guys, you will also get guidance and strategy sessions in these pro subscription. So those of you who are asking me the price, this is the price, 42,749 rupees, again using the coupon code. Like I was saying, it's 3,000 rupees per month. This is the light version. You get everything what I told you. Additionally, if you want doubt solving after the class, which many people go for, this is what you go for, 54,449. So that comes out to 3,870 rupees per month. I would say at least try it out for 1 month. In this plus version, you'll get personal mentorship, will guide you how to study, make timetables, plan your strategies, and help you out with your personal problems as well. That's what it is. Hi KRMS, welcome aboard. Thank you Krishna Bacha. Okay, easiest question was it? Please Tsunami. So how has the journey been, guys? Okay, so officially this will be the last teaching class of mine for 2021 batch, because I don't think you are in a mood to study any more physics. How many of you are okay sir, done. Now please tell us about counseling, please tell us about which colleges I can go for, or please tell us about the dropper batch. Anyone. So I'm pretty sure you don't want any more studies, you want to enjoy. So guys, do not forget there is a session of mine tomorrow at 7:30 where I'm going to talk about the movies you can watch. Especially all the science students will enjoy watching this. Okay, yes, new ICER will be worth it if you are interested in research or PhD or becoming professors or going into R&D in some company. Yep, it will be worth it. Gokul, if you want to take drop, don't worry bacha, we are still here. You can still watch our 11th and 12th standard classes. Number 2, dropper batch is starting. Please check the link in the description box. It's just there, it's over here. Okay, just check this out. If you go to this lecture, okay, you will see it right over here. Okay, you can see the dropper batch link. So just click on this link and join it. That's simple. Okay, so that's what it is. Okay, cool. So thank you guys very much. Now Shimon sir will be joining in very soon. Let me just check with Shimon sir if he's ready. Most likely he should be ready, guys. But still, let me just check once more. I'm not sure. Okay, so I'm not sure if Shimon sir will be joining in or not. I think he's not feeling well, but okay, anyways, you will have the class very soon if needed. Okay, chalo guys, bye bye, take care. If you have anything to say, please let me know in the comment section below. Bye bye, have a great time. This was Shreyas here, your captain. Hasta la vista, guys.